In this video, we're going to look at how to compare and order decimals, or how to compare and order decimal numbers. We are going to be using the symbols of less than, greater than, or equal to. So there are basically two ways that you can go about comparing and ordering decimal numbers. So let's first focus on comparing decimal numbers to each other. One thing that you can do is take your two decimal numbers that you want to compare. Let's say you've got 47 hundredths and you want to compare that to 83 hundredths. The first way that you can compare them is basically to compare each digit in its place to the matching digit in its place on the other number. So for example, I would first look at the digits in the ones place. Well, since they are both zeros, I can't use those to compare by. So I'm just going to mark those out and I can't use the zeros. Then I would go to the next highest value digit, which would be the tenths place digit. Now, in the one on the left, the digit is 4. The one on the right, the digit is 8. Since they are both different digits, all I have to do is to compare these two individual digits to each other. 4 is less than 8. So that would mean that 47 hundredths is less than 83 hundredths. This would also work no matter how many digits that the decimal number has, because unlike on decimal numbers, unlike whole numbers, you cannot look at the number of digits that the number has to determine if one's bigger or smaller. Here's an example. In a whole number, if you were comparing 1,284 to 93, then obviously 1,284 is greater than 93. Both of these are whole numbers. The one on the left has more digits than the one on the right. But in decimal numbers, it does not work that way. Let's look at this example. Let's say you were comparing 1/10 compared to 13 thousandths. Now, many students would immediately look and say, oh, well, this decimal number only has one digit. This decimal number has 3 digits. So 1/10 must be less than 13 thousandths. Well, this is not true, because if we look digit by digit and compare them, we would see something different. So let's first look at the ones place digits. Since they are both the same, I cannot compare by using the ones digits. Now let's look at the tenths place digits. I have a 1 and a 0. These are the first digits that are different from each other. So I would compare the 1 to the 0. 1 is greater than 0. So 1/10 is actually greater than 13 thousandths, even though it does not have as many digits in the number. Now, let's see why that occurs. So I'm going to rewrite this problem again. 1/10 compared to 13 thousandths. Now, this gets into the other way that you can compare decimal numbers to each other. If I wanted to take 1/10 and make it equivalent decimal out of it up to the thousandths place, all I would have to do is add 2 more zeros to it. And if you remember, what we've learned in the past is when you add zeros to the end of a decimal number, it does not change its value. Now, if I turn this into a fraction, 100 thousandths, so 100 over 1,000 compared to, turn this one into a fraction, 13 thousandths, 13 over 1,000. Here's one way you could interpret this. If I had a bag of M&Ms that had 1,000 M&Ms in it, and my best friend had the exact same size bag, and it also had 1,000 M&Ms in it, I ate 100 M&Ms out of the bag. My best friend ate 13 M&Ms out of the bag of 1,000. So who ate more? Well, obviously, I ate more. So 100 thousandths is greater than 13 thousandths. Since 1/10 is equivalent to 100 thousandths, this is why 1/10 is greater than 13 thousandths. So you can also add zeros to the end of whichever decimal number that you need to in order to compare them to each other. Let's take a look at another example. And once again, we're going to just focus on comparing them right now. Let's say you've got 0.4 4/10 compared to 0.1847, 1,847 10,000ths. So first of all, I can either add zeros to the end of my decimal number to make them both equivalent out to the same place. Well, since this number goes to the fourth place behind the decimal, I need this number to go to the fourth place behind the decimal. So to do that, or in other words, equivalent to the 10,000ths place, I would simply add 3 zeros to the end. So this would be 4,000 compared to 1,847. Or remember, that's really 4,000 10,000ths compared to 1,847 10,000ths. So obviously 4,000 M&Ms out of a bag of 10,000 is greater than 1,847 M&Ms out of a bag of 10,000. So that's adding zeros to the end. If you do not add zeros to the end to make it equivalent, all you need to do is compare each digit in its place or in a matching place with the other one. So the ones place digits are the same. I can't use those to compare with. The very next digit, the tenths place digit, is different. 4 compared to 1. So these are the only two digits I need to look at. 4 is greater than 1. Now, what happens if you have whole numbers with your decimal numbers? Let's say you've got 23 and 1400ths compared to 47 and 1400ths. Since we have whole numbers this time, we first need to check the whole numbers. Well, the whole number 23 is smaller than the whole number 24. It doesn't matter that the decimal numbers are actually identical to each other. I don't even need to look at those to compare them. 23 will always be less than 47. So don't forget to also check out the whole numbers. Now let's move on to ordering decimal numbers. When you are ordering decimal numbers, you are either asked to put them in order from the least to the greatest, or sometimes you'll be asked to put them in the opposite order from the greatest to the least. So let's take a series of decimal numbers. One of the best ways to do this is to line up the decimals or the decimal numbers one right under the other to get the digits in their places lined up. So let's say you have 1/10, 400ths, 1300ths, and 427 thousandths. So I now have these lined up. So let's say that for this particular problem, I want to put them in order from the greatest, listing the greatest decimal number first and going in decreasing order down to the smallest or the least one. So I compare my digits in each place. All of the ones place digits are the same, so I can mark those out. I don't need to look at those. Now in the tenths place, I have a 1, a 0, a 1, and a 4. Now I'm trying to find the greatest number first. So between 1, 0, 1, and 4, 4 is the largest digit. So I know that this number is going to be placed first. 0.427, 427 thousandths is the largest number. Now, since I am finished with it, I'm just going to mark it out. I don't even need to look at that one anymore. If you want to, you could also erase it, just so it's not as confusing. Now, I've got my greatest number. I need to find the next largest one. So I have, once again, I'm still in my tenths column, a 1, a 0, and a 1. Well, since ones are bigger than 0, I need to decide between this one and this one. So now I'm just going to look at these two. I'm going to totally ignore the one in the middle. Well, since the ones are exactly the same, I can eliminate those. I don't need to compare by the tenths place digits. So now I go to the next place, which is the hundredths place digit. Well, here we have a 3, and up here there is nothing. However, what really could be there is a 0. Well, 3 is always going to be bigger than a 0 or nothing, so this is going to be the next largest one. 0.13, 13 hundredths. So now I can get rid of this one. Well, obviously, since I was deciding between the top one and the bottom one, this one would go next. The next largest is 0.1, 1/10. And then finally, the smallest one would be the last one, 0.04. Now, another way that we could check to be sure that I have the correct order is by also adding zeros to the end. Now, my top number, 427 thousandths, goes out to the third decimal place. So I want all of my numbers to go out to the third decimal place, or the thousandths place. And without changing the value, all I have to do is add zeros to the end. So on this one, I add 1 0. On the next number, I would add 2 zeros. And on the last number, I would add 1 0. Now, it's just like looking at whole numbers. The largest number, that is if you thought of these as whole numbers, would be 427. The next largest would be 130. After that would be 100, and the smallest one would be 40. So I do have the order correct, but I'm going to erase the zeros because those were my original numbers. And that's really all you have to do to compare and order decimal numbers. I hope this has been helpful to you.